So today we're doing our second triangle center called the Incenter, and like the objective says, we're going to be able to draw angled bisectors to construct an incenter and apply incenter properties. So you should have already copied down the third line. I know it's kind of weird. We skipped the second one, the third section on the fill-in notes. You want to fill that in. If you didn't get this yesterday, you can get it out of the blue bin under the date 11/28, and you can start filling that in. I'm also going to have copies of keys of that on the walls if you get behind. But let's take a look at the notes for angled bisectors and incenters. Okay, so it says a triangle has three angles, so it has three angle bisectors. And we all remember what a bisector is. It cuts an angle in half. So the angled bisectors of a triangle are also concurrent, which means, the three lines intersect. That's what concurrency means. Okay. So this point of concurrency is called the incenter. So last time it was a centroid, now we have an incenter. Now let's look at the incenter theorem. The incenter of a triangle is equidistant from the sides. Okay, so I want you to definitely draw this. So everybody, looking at this little picture right over here. Okay, if you're looking at this, you see the red and the blue segments. Does everyone see the blue segments start at the incenter, which is point P, and go to the sides? So this theorem said from the incenter to the sides is this word equidistant. So that means I'm going to put tick marks here, here, and here. Okay? All three of those blue segments that go from the incenter to the edge and make a right angle are all equidistant, meaning they're all congruent. Okay? So all three of those little segments from the incenter to the edge, making a right angle, are congruent. So if you know this information, then these next couple problems shouldn't be that bad. So look at number one. Segment JV and KV are angled bisectors. Okay? Now, anytime you see the phrase angle bisectors, you want to show me that it cuts the angle in half, and you show that with arcs. So, if JV is an angle bisector, that means angle WJV and angle VJL, those two are equal. I'm going to put one arc on both of them. Then it says KV is an angle bisector, so KV is over here. If KV is an angle bisector, that means angle WKV, two arcs, and VKL, two arcs. Those are going to be equal. Do you see how I'm showing you it's an angle bisector? Because it creates two equal angles. Find the distance from V to segment KL. So I want to know the distance between V straight over to KL. Okay? Now, what do I call this point right here in the middle if it's created by angle bisectors? Well, from the top of this page, we learned angled bisectors create what's called the incenter. So that means this point in the middle here, point V, is an incenter. Alright, so V is an incenter, then we know it is equidistant to the sides. So I'm going to do this in red. V to W to the side, making a right angle, is 7.3. The question is, what is V to this side with the right angle going to be? Well, theorem said earlier, these are equal sides, so this little segment has to be equal to the other one, so it's going to be 7.3. Now, is that easy? Yes, if you know something about incenters and angle bisectors. So again, if you see angle bisectors, it makes an incenter, so these little segments to the sides are going to be equal, 7.3. Easy? Yes. Okay. On the back, number 2, segments QX and RX are angle bisectors. So again, if QX is an angle bisector, arc, arc. If RX is an angle bisector, double arc, double arc. Find the distance from X to segment PQ. So from X to segment PQ with a right angle. And remember, since I have angle bisectors, that means X is an incenter. And if X is an incenter, it's equidistant to the sides. So this side right here is equal to this side right here in measurement. So if XY is 19.2, from X to PQ, okay, is going to be 19.2. They're equidistant. And now we want to find that's one thing, segment PQ, 19.2. Okay, the distance from X to segment PQ, right? And the measure of angle PQX. Now, PQX is right here, okay? Now, before we can find PQX, we need to think of the whole big triangle, okay? So, look down here at angle P. This is 52, right? I'm looking over here at angle R, and half of angle R is 12. So guess what this right here is going to be? 12. So here's the question. All together, this whole angle, if half is 12 and half is 12, the whole thing is 24, okay? So, angle R, the whole angle R is 24 degrees. Now, what I'm going to do is I'm going to redraw this triangle off to the side here. This is 52. This is 24. What is the third angle? I can easily find that out by adding the two angles I know and subtracting from 180, right? We've done this before on the last unit. So 52 plus 24 is 76. And then I'm going to take 76 away from 180, right? And I get 104. So this whole big angle right here is 104. Am I looking for this whole angle over here? No, not all of Q, okay? I'm looking for half of Q, right? Half of that whole angle Q. So all I got to do is 104 divided by 2. I get 52 degrees for each of these. So PQX equals 52 degrees. So now you're able to finish this assignment. This assignment we got 2 days ago, okay? So the front side is Alright, the front side is median and centroid practice. This is what we've been doing the last 2 days. So the first 3, make a centroid by connecting 3 medians. Look at your notes. 4, 5, 6, and 7. This is based on what we did yesterday. Look at your notes from yesterday. And then the back side is what we just did. So the 9 through 14, okay, should be not too bad. Okay, 15 might be a little bit more challenging, kind of like what we just did. Just remember on 15, if you know two segments are congruent, even if they are expressions, set them equal and solve, and then you can plug it back in and find an equivalent side. Okay? So your assignment is going to be to knock this out, front and back, based on what you learned about centroids and incenters from medians and angled bisectors. And if and when you finish this, make sure you have knocked out all your missing work and that extra credit from before the break. All of it's in the blue bin. All right.